This is FRQ project number 2 with Rowan, Sanger, Calvin, Trevor, Ethan, and myself. We did problem 24, which focused on calorimetry and enthalpy, and it's asking us to calculate the amount of heat needed to purify 1 mole of aluminum, which was originally at 298 Kelvin by melting it. So using the equation Q equals C times M times delta T, which is right up here, we can see that these variables correspond to what is given to us in the problem, and plugging those values into the equation gets us this value of Q. The only thing that we have to do is calculate specific heat because it gives it to us in joules divided by moles times Kelvin when we really want specific heat in joules divided by grams. And to do that, we just divide the specific heat in joules divided by moles. And divide that by the molar mass of aluminum, which is 26.98 grams, and that gets us 0.89 joules divided by grams times Kelvin. The equation also gives us the heat of fusion of aluminum, which is 10.7 kilojoules per mole. Converting that to joules to be able to add it to the Q value that we found, which was 15,247.7 joules, we get 25,947.75 joules per mole, converting that to kilojoules, making it 25.947. Number 2 is asking us to compare these reactions that we have, this one being extracting aluminum from Al2O3 versus recycling the existing aluminum and seeing which one requires less energy. So here we know the recycling of aluminum costed 25.947 kilojoules, whereas this equation, which would be extracting the aluminum, took 1,675 kilojoules per mole. So that brings us to the answer for number 2. Recycling takes less energy than extracting aluminum from Al2O3. Thank you.